Hi friends, it's Miss Eliza, Children's Librarian at the Waukee Public Library, and for this month's Elementary Maker Project, we are going to be making cardboard paddle boats. These super simple boats demonstrate two of the laws of physics, the law of conservation of energy and Newton's third law of motion. To do this project, you're going to need a piece of cardboard. Any old cardboard box will do. You're also going to want to have scissors, a ruler, pencil, rubber bands, and you're also going to need some duct tape. If you got a pack from the library, you've got some strips of duct tape here on wax paper, and that just makes it a little bit easier to transport, but you can, of course, use duct tape from a roll as well if you're at home. To start making this boat, you're going to construct the hull, which is this base part, but we're going to start with just a rectangle. So you're going to measure a rectangle that's about 3 inches and by 5 inches, and you can use that with your ruler and pencil. Once that's measured, you're going to go ahead and cut that piece out. All right, and then to give it the boat shape, you're going to want to cut the corners off of the top part just to make that rounded edge shape of the boat. And you can experiment with this. Maybe you want to make a couple different ones and see what shape of boat hull actually works the best, helps it propel further. That's something that you can kind of adjust in this experiment and see what takes. All right, so we've got the base kind of boat shape, and then you're going to need to cut out a piece in the middle to make the paddle. So you can see we're going to cut out a smaller rectangle about halfway into our hull, and that's going to create this space. And then we're going to cut down that empty piece that we get out of the middle and make it slightly smaller so that it has room to spin. Okay, so we've cut this shape out here, and you can see this is going to fit right back up in there, but without any wiggle room. So we're going to want to cut this down so that it's slightly smaller than the space that you cut out of your hull. All right, so now we've got our hull and our paddle, and make sure that you get a grown-up's help cutting cardboard, especially if it's giving you any trouble. So before we put this in the water and actually get it to work, we're going to need to make sure that we make it waterproof, because cardboard is porous, which means that the water is going to soak in, and when that water gets into the cardboard is going to be super heavy and it's not going to float on the top of the water. So that's not a very good boat. That's where the duct tape comes in. So you're going to want to wrap all of the boat, all sides, and the paddle in something waterproof. We're going to use duct tape. There are other things that you can use. It doesn't have to look pretty, it just needs to cover all the surfaces. So we're going to wrap this up. Okay, I'm back, and we now have our hull and our paddle completely covered in duct tape, and you can see it looks a little sketchy. It's not super pretty, but that doesn't matter. It's just trying to be waterproof. You also want to make sure that as you're adding duct tape to the paddle, it's going to add some width, so make sure that it still fits inside the middle of your paddle boat and that you're not losing any of the wiggle room there. So then to construct it and actually make it go, you're going to put a rubber band around the 2 legs of your paddle boat, just like that, and then you'll slide the paddle in so that it's in the middle of the rubber band. Then you're going to make sure that the hull is facing away from you, and then twist the paddle towards you. So you're going to want to twist this up about 20 times so that it's pretty tight, but you need to hold on to it because otherwise it's going to unspin. And what's happening here is that we're creating some potential energy in the elasticity of the rubber band by creating this tightness here. So when we let it go, it should turn into kinetic energy. That's the energy of motion, and it should propel the boat forward. Now, once that happens, when it's in the water, the third law of motion tells us that the water is going to have a reaction to the motion that's happening in the paddle. So as the paddle spins, it's going to push the water away, and that should help us move forward. These 2 laws of physics combined explain how paddle boats work. So hold on to it. Don't lose that potential energy. We're going to transfer it over into our bucket of water, and we'll see what happens. Okay, so we've got our paddle boat. I twisted the paddle a whole bunch of times towards me, keeping the same side up. We'll see what happens if we get the sides switched. So then you'll put it down in the water, just right on top, and then when we let go of our paddle and release that rubber band, let's see what happens. All right, so you can see that spinning kind of unwound the rubber band and it ended up pushing our boat forward. Okay, so I wound it up again. Let's check it out. Oh, so see what happened here? Remember when I was saying that you need to make sure that your paddle is the right size to fit into the hole that we cut out of the hole. So here you can see this corner got stuck up on the end, and so it didn't spin quite as much as it maybe could have if we had a better paddle to hole ratio. So if that happens, you can just cut another piece of cardboard and reshape a paddle that might work a little bit better. Here, let's try a slightly different design. For this version of the boat, I tried to cut a slightly longer paddle, one that was a little bit bigger, hoping that it would displace a little bit more water and get some further forward motion. Let's try this one and see what happens. So again, we're getting a little bit caught up here on the edge. You can kind of trim it down and make sure that you find one that's the right size and shape for the hull of your boat. All right, so now that you know the basics of making these paddle boats, there are all kinds of different ways that you can explore and see if you can get one that moves faster or further. We just had a little plastic tub full of water, but you could do this same project and take it out to a bathtub or a kiddie pool. Probably not something with running water, although that could be interesting, see what you can do. But you can experiment, see if you make a bigger one, what happens. See if you can change the shape of the paddle. What if it's longer? What if it's a little bit wider? What if it's a little bit heavier? Is there anything that you can put on top of your paddle boat and it'll still float and move forward? You saw in our example that we were running into some issues with the paddle getting caught on the sides of our hull. So you might want to cut down the size of your paddle or even repair pieces of your hull. You might also notice that as it goes on, the boat is getting a little bit wet and it's holding on water and it's not floating as well. That's going to make it harder to propel the boat forward. Are there other ways that you can waterproof it? What happens if you add an extra layer of duct tape? There's a lot of different ways that you can explore with this project, but hopefully you can see a little bit about how the law of conservation of energy, wrapping it up in that rubber band and then releasing it to move it forward, as well as the water being displaced, pushed aside. That third law of motion where the paddle is pushing water away, and for every action there's an equal and opposite reaction. So the boat's reaction to the paddle pushing that water away is to move in the opposite direction, and that's how we get that forward momentum. It's a really good way to illustrate those two laws of physics, as well as have a little bit of fun making a cardboard boat. Thanks for joining us. We'll see you next month. Bye.